Warning: diethyl ether is highly flammable. Fire safety protocols must be in place. Greetings, fellow nerds. Diethyl ether is a very famous and commonly used solvent in chemistry labs. It's nonpolar and has a very low boiling point of just 34.6 degrees Celsius, lower than human body temperature. So that makes it easy to remove from chemical reactions by boiling it off. This is tremendously useful for solvent extractions. Additionally, it's not very reactive, but polar enough that it can support Grignard reactions. I want diethyl ether for both purposes. Now, diethyl ether can be made from sulfuric acid and ethanol, but a much more accessible source is car starter fluid. This is usually a mixture of diethyl ether and N-heptane. Other sources may have other components, but almost all of them have diethyl ether. If you buy these cans in bulk, this can be a far cheaper source of diethyl ether than making it yourself. Now, to separate out the ether, we're going to distill it. First, spray the contents into a flask. Mine didn't come with a spray straw, so I'm using this distillation adapter to direct the spray into the flask. This is completely optional though. I'm just using it because it lets me hold the can upright. I'm wearing a glove because the can was previously cooled in a freezer overnight to lower the temperature. This is to help reduce evaporative losses. Nonetheless, some will escape, so do this outside or in a fume hood. Anyway, here's our flask of car starting fluid. Now to separate out the ether by distillation. Set up a fractional distillation apparatus around the flask. Now, the cooling water you use should be ice cold, so I recommend using an ice water reservoir. Diethyl ether has a low boiling point of 34.6 degrees Celsius, so room temperature cooling water will have diminished effectiveness condensing it. Now turn on the heating and start distilling. Start off at a very low temperature and very slowly ramp up. Diethyl ether is very volatile and it doesn't take much heat to start it boiling. If you prefer, you can use a warm water bath instead of direct heating on the hot plate. Now, you don't need a fractional distillation setup and simple distillation will work. But I prefer fractional distillation as heptane is still quite volatile in of itself, and a small length of fractional distillation column greatly improves purity. As you distill, the flow will drop and you'll need to raise the temperature as you progress. Try to keep a constant flow. Go in small increments and wait for the temperature to stabilize before going further. Diethyl ether can boil so fast that it blows apart the distillation apparatus. Considering it has a very low autoignition temperature, it can easily catch fire if the vapors find their way to the hot plate. So go slowly. It's for this reason that many chemists prefer to boil ether with hot water, as hot water is below the autoignition temperature of diethyl ether. Eventually, as you continue to increase the heating in small amounts, you'll reach a disproportionately large spike in distillate temperature for a small incremental change in heating. When the temperature shoots past 70 Celsius, even though the flow rate is very low, you're done distilling diethyl ether and are now starting to distill heptane. Stop heating and let everything cool. And here it is, diethyl ether distilled from car starter fluid. Now, a special note about long-term storage. Diethyl ether, like most ethers, is notorious for reacting with air and light to generate highly explosive organic peroxides as it sits in storage. This is relatively safe in small concentrations, but if you evaporate the ether or distill it off as you would for solvent extractions, then the peroxides would concentrate in the residue and explode. So don't keep diethyl ether for extended lengths of time. Use it within several months. Alternatively, you can store diethyl ether over sodium hydroxide or sodium metal. You can even use the sodium magnesium oxide aggregate I showed how to make in a previous video. To be honest though, don't even bother storing your ether separately. Instead, keep the original can and only distill it out when you want to use it. Distilling it out and not using it is kinda unnecessary. In here, it's protected from light and more importantly, there's no air, only carbon dioxide propellant. So it can last many years without peroxide formation. Anyway, let's say you distilled it out and have used it. You might be wondering what to do with the leftover heptane residue. It's actually a nice clean aliphatic solvent and wonderful for cleaning oily residues and contaminants. It's very inert and you can even store sodium metal in it. In fact, it's great for washing off the mineral oil from sodium if you want relatively clean sodium for your reactions. Heptane itself evaporates quickly and can also be distilled out if you prefer. Being clean and nonpolar, it's also an excellent solvent for solvent extractions. So you can get two very useful chemicals from starter fluid. I'll be using diethyl ether for solvent extractions and Grignard reactions in upcoming videos. Thanks for watching.